Good morning, students. So today we are going to study the important questions of the amines. Of course, it has only little bit reactions. I have completed in this class only. So in this amines, okay, this 5 marks compulsory question. You know that I already explained. Okay. So students here in that amine, the main first question is nomenclature. In amines, the importance questions. Second one is classification. Third one is preparation, that is reduction with nitrobenzene. Reduction with nitrobenzene. Second one, Mendel's reaction. So what is this Mendel's reaction? Means reduction of reduction with nitrides. Okay. Next, third one is reduction of amines. Very easy one. Okay. Next, fourth one, Gabriel Thalamide synthesis. So Gabriel Thalamide reaction. Gabriel Thalamide reaction. Okay, so the next one, the acidic character, basic character, and its structure is there. So later I'll explain the nomenclature, classification, and acidic and basic nature of all the compounds. At that time I'll explain. So the next one is what is it? Okay. Bromination. Next, carbylamine reaction. Carbylamine reaction, very important. Next, seventh one, same acylation, sulfonation, and nitration. Only these are important. So students, another one is there, that is diazonium salts. The preparation of diazonium salts, their preparation, their properties and all, that is removed from your syllabus. So I want to explain it. And another one is the reaction with sulfonyl. Benzene sulfonyl chloride. I hope benzene sulfonyl chloride. Benzene sulfonyl chloride called as Einsberg reagent. Called as what? Einsberg reagent. This is one of the distinguished tests between primary, secondary, and tertiary amines. So in the classification, I will explain primary, secondary, and tertiary. Just remember, we will go with reduction with nitrogen. Only chemical reactions we will discuss later in the tomorrow's class. If it is completed in today's class, in the tomorrow's class we will discuss the nomenclature of allyl, alcohol, phenyl, ether, cardiac ketones, and carboxylic acids, and the amines. Okay? So we will discuss one by one. Be with these reactions. Okay? Once again. Okay. So students, the first one is reduction with nitrobenzene. So third one. Okay. Reduction with nitrobenzene means here the reagent used is what? Nitrobenzene. Okay. So the reaction or reagent used here is what? Clearly listed nitrobenzene. Reduction means, of course, H2, addition of hydrogen. Here the thing is, we need to take palladium as a catalyst and ethanol as a solvent. Okay, then they form, no doubt, NH2 compound, that is benzene amine. So this one is nitrobenzene. So this one is benzene amine. Okay, and this is simply called as aniline. Means benzene with the NH2 group is called as aniline. So students, how the explanation here? Only the simple thing, reduction with nitrobenzene means nitrobenzene undergoes reduction in presence of palladium as a catalyst in ethanol solvent. I will take ethanol as a solvent. Gives an alkane. This is one reaction important for 2 marks. Okay, so the next one is reduction with the fourth one, that is Mendes reaction. What is that Mendes reaction? Reduction with nitrites. So students, this is not a general reaction, particularly we are taking nitrobenzene and we are getting this amine. But in that, we are taking a general reaction like nitrites means RC triple bond N compounds. They undergoes reduction. Okay, so here the reagents used are lithium aluminium hydride. Lithium aluminium hydride. Sorry. Okay. It may be lithium aluminum hydride or catalytic hydrogenation in solvent or alcohol lubricant, that is C2H5. Same. Here also reagent same. Here either this or this. Are you getting? So then of course double addition takes place and they form RNH2 plus RCH2NH2. Primary. So this is alkyl nitrates. Okay, so students, how do you write? Listen, alkyl nitrites undergoes reduction in presence of lithium aluminum hydride or catalytic hydrogenation gives primary amine. This is the explanation. So if you take example 1 for that next year. So in the place of R, just to replace CH3, C triple bond N. So followed by this lithium aluminum R, this catalytic hydrogenation. This is the catalyst, this is addition of H2, that is catalytic hydrogenation, gives CH3, CH2, H2. So students, this one is alkyl nitride means methyl nitride. So this one is ethane, the first two carbon atom, last is replaced by the functional group amine, ethanamine. How do you write? So in the place of alkyl nitride, take methyl nitride undergoes reduction in presence of lithium aluminum hydride or catalytic hydrogenation gives ethanamine. This is the example. Okay? Okay. So students, next the third one is, so the third one, fifth one is reduction of amines. Reduction of amines. Okay. So in this reduction of amines, just like the general reaction of amide R3 double bond O NH2. So this undergoes reduction in presence of lithium aluminum hydride first. The second one is followed by hydrolysis. To react to it undergoes reduction in presence of lithium aluminum hydride followed by hydrolysis gives CH2 NH2 plus H2. It is primary amine, or you simply take amine. This one is amine. This one is amine. Okay? Then how do you write? Amines on reduction with lithium aluminum hydride. So followed by hydrolysis gives, what is this? Amines. These are for only preparation methods and they are important for only 2 marks. Are you getting? So here, if you take the example, you may take benzamine, acetamine, anything. This R group may be replaced by anything, but I take only example. Here I took CH3, so here I take, okay. And take CH3 also. CH3, C double bond O, NH2. So first one is reduction with lithium aluminum hydride. The second one is hydrolysis. And they form CH3, CH2, NH2 plus H2. So students, this is 2 carbon atoms are there, that is ethane. Last is replaced by amide group, ethanamide. This one 2 carbon atoms here, that is ethane, last is replaced by amine, that is ethanamine. Now, so in the place of amine, take ethanamine on reduction with lithium aluminium hydride followed by hydrolysis gives ethanamine. Everything remains same, students. In whether it may be a aldate ketone carboxylic acid reaction, alloalkane alloaldehyde reaction, alcohols phenol ethyl reaction. Any one general reaction is there. The explanation remains same. The thing is only you have to replace the name of the reagent and the product by replacing any of the respective argument. It may be CH3, it may be C2H5, it may be a benzene ring, it may be alkyl substituted benzene ring. No matter what it is. We don't bother about the argument, reaction takes place here. Here also we don't bother about the argument, reaction takes place in between these two. So where the reaction taking place, that we need to remember. We don't bother about the argument. It may be a bulk here. Understood? So this is all about preparation. So another one is there, that is Gabriel thalamide reaction. Actually students, this Gabriel thalamide reaction, they won't ask in the examinations. Before they didn't ask, they don't give much importance for that. They always choose diazonium salts over this Gabriel thalamide reaction. But for your syllabus, in this year, they cancelled the diazonium salts, their preparation, their chemical properties and okay. Even though I already explained what is that diazonium salts, how they are prepared. Okay. Listen, for your syllabus that is removed, that's why there may be a chance of giving preference to this thalamide reaction. So now, Gabriel thalamide reaction. Okay. So in this reaction, we are going to take thalamide as an example reagent here. C double bond O, C double bond O, NH. So this is what? Thalamide. So students, this thalamide is going to treated with KOH. Then water molecule is removed. OH from here, H from here. So then what happens? They form, same follows here. This one is C double bond O, C double bond O, N, N. In the place of H, K will go. H plus, that is K plus. So here, this is potassium salt of thalamide. Potassium salt of thalamide. So students here, this is treated with RX compound. That means alkyl halide. Then KX is given. Here R is attached. Then here C double bond O, C double bond O, N, R. Okay. So again it is treated with what? Aqueous NaOH solution. Aqueous NaOH solution. Then what happens? This will give C double bond O, C double bond O, ONA. plus R NH2. Okay, so this one is amine. This is sodium alkoxythalamide. Okay, or this is C double bond ONA means sodium alkoxy compound it is. Are you getting? So this is our report. What is this? Gabriel thalamide reaction. What is the process taken here? The thalamide initially react with ethanolic KOH. Remember, alcoholic KOH. Ethanolic KOH. So water is removed. They form potassium salt of thalamide. It is further treated with alkyl halide. When it is treated with alkyl halide, they form this alkyl substituted thalamide. Okay, this is what? Alkyl substituted thalamide. So if it is CH3, then methyl substituted thalamide. C2H5, methyl substituted thalamide. So followed by this, aqueous NaOH means hydrolysis takes place here. When it is treated with H2O, hydrolysis takes place. Okay, they form amine and this product. So students here in this, they won't ask any explanation here, and if they ask, how do you write? So thalamide reacts with ethanolic KOH, forms this one, potassium salt of thalamide. Okay. Again, it reacts with alkyl halide followed by hydrolysis with aqueous NaOH gives amines. This is what the explanation. Explanation is not needed because as this is a complete reaction. So nowadays, still until they won't ask this thalamide synthesis reaction in the examination. They won't give much preference. But this year, it may be considered as an important question because as I told you, the diazoxide salt topic is removed from your syllabus. So if anything to be asking for 5 marks, this must be a 3 marks question or a 2 marks question. 3 plus 2, 2 plus 1, 2 plus 2 plus 1 like that. Okay? So be concentrated on this. So the next one is of course this is all about the preparation. Next we are studying the chemical properties. So students, another one reaction is there, ammonolysis. Actually that is not important, even though I will explain. Ammonolysis. Okay, that is not important, even though I will explain. Remember that. Ammonolysis. Ammono means amine group, lysis means breaking. So breaking of that amine group. How? So listen, this RNH2 compound is there. It is treated with RH type compound. Or if you take before that, so first step, NH3 is there. It is treated with RH type compound, forms RNH2 plus HX. This RNH2 again treated with RH type compound, form RNHR plus HX. Means each hydrogen from this ammonia is replaced by this R group. Then RNHR again it is treated with RH. Therefore RNR plus Hx. Then consider this again, that is Rn or R plus Rx gives R, N, R, R, that is R, that is X. Okay, R4, Nx, N plus X minus. This is plus, this is minus. So students, this is primary amine, this is secondary amine, this is tertiary amine, this is quaternary amine. Okay, what is ammonolysis means the conversion of ammonia into quaternary amine, quaternary ammonium salt. Not quaternary ammonium salt. Conversion of ammonia to quaternary ammonium salt by reacting with this alkyl halides called as ammonolysis. So still this is also they won't ask, but remember if they ask what is ammonolysis, conversion of amine to quaternary ammonium salt by treating with this alkyl halides. This reaction is also present in the alkyl halide compounds. They are also explained already. Okay, if you want, you can check. So this is still they won't give much importance for these two reactions, but this year there may be a chance of asking these, as I told you, because the syllabus is reduced. Okay, so the next one is bromination. That is fifth one. Bromination. So students, if only bromination will consider the primary amine, or we consider directly the aniline. This aniline, it reacted with bromine water. Bromine water, therefore, tri-substituted compound means here NH2 is there, means ER1Br, ER1Br, ER1Br is attached. Okay, so that is 2, 4, 6 tribromo and lean. Important for 2 marks because this is only the different reaction compared to electrophilic substitution reaction. If acylation is there, sulfonation, nitration, that takes place in different manner. When it comes to bromination, when it directly reacts with bromine water, they form 2,4,6 tribromo and lean. Understood? Okay. So the next one is carbylamine reaction. Very, very important. Carbylamine reaction. Okay. So students, in this carbylamine reaction, okay. So primary amine is treated with chloroform. In presence of QH. Which type of QH? Alcoholic QH. Means primary amine is treated with chloroform in presence of alcoholic QH forms RNC compounds. Means isocyanides. Alkyl isocyanides along with KCl 3 moles plus H2O 3 times 3 KCl 3 H2O. Okay, so this is primary amine. So this is chloroform. And this one is alkyl isocyanates and that potassium. So students, this reaction is very important for 2 mark. And this reaction is also one of the identification reaction or a detection of functional group reaction. Means, so if we are writing, we are taking some of the organic compound, we don't know whether it is amine or something else. So we take on that. When we choose, in the test tube we are taking amine, we don't know whether it is primary, secondary or tertiary. So when the chloroform is added to that in presence of alcoholic units, this isocyanates will form. How can we came to know the former compounds are isocyanates? Means they form a bad odor. These are called as what? Carbylamine. They form what? Bad odor. That's why this reaction is called as carbylamine reaction. So if the bad odor forms, then we came to know alkyl isocyanates are formed. But you write, so primary amines on reaction with chloroform in presence of alcoholic OH gives a bad odor of alkyl isocyanates. Is carbylamine. This is what carbylamine reaction. Important for 2 marks. Understand? Okay. So this R group may be replaced by any alkyl or any aryl. Remember, it must be a primary amine. If secondary amine is there, they won't form this type of amine. They won't form alkyl isocyanates. Okay? This is very easy one, students, because only few reactions are there and this chapter is carrying 5 marks. If you practice only few reactions, you will get 5 marks. But in adults and ketones, it is not like that. More and more reactions are. Of course, it carries too much marks. Then also. The next one is Hoffman bromide reaction. Okay? Hoffman bromide reaction. This is also name reaction, very important for 2 marks. So students, initially I didn't written this. Okay, in the important portion I didn't mention this. Just write a Hoffman bromide reaction. So what is this Hoffman bromide reaction? What it tells us? So listen. So we are considering amide here. Okay, so this amide is treated with bromine and NaOH. Alkaline bromide. Often this amide is treated with bromine in presence of NaOH. So therefore, RNH2 type plus NaBr plus Na2CO3 plus H2O. So students here, 3 moles of NaOH we want because we have to balance. This is what Hoffman bromide reactions. This preparation of amines from this amines. So this is amide. This is amide. Okay, listen here. Hoffman bromide reaction. Here amide treated with bromine and NaOH solution gives amine. This reaction is called as Hoffman-bromamine reaction. Okay. So next one is similarly reaction with sulfonil. Okay, I'll just write this because I need to write distinguished ST and it's for reagent. So students here, reaction with sulfonil, benzene sulfonil chloride. Benzene sulfonil chloride. Okay. So in that benzene sulfonil chloride means we have to take amine. Consider this is the benzene sulfonil chloride. Okay, so benzene sulfonate chloride is there. If it is treated with primary amine means NH2R. This is secondary amine, and this is tertiary amine. If nitrogen is got into 1R, primary amine. If nitrogen got into 2R, that is secondary amine. If nitrogen got into 3R, that is tertiary amine. Remember what happened? So students, so here HCl is removed. Then the compound formed is like this. This is benzene, sulfonil, and this is NH. So here again HCl is removed. Then it is this benzene ring is double carbo, NR. And this one is there is no reaction. Okay, so students, this is white PPT. This is also white PPT. So if you add NaOH here, so this is soluble. So if you add NaOH here, this is insoluble. So this is the distinction. Here no white PPT means reaction taking place like this. Here hydrogen is there, HCl is removed. Here hydrogen is there, HCl is removed. Here there is no hydrogen, so there is no formation of such type of compound. So here there is no white precipitate. So students, how do you write here? Amine plus Ainsworth reagent. What is the Ainsworth reagent? Benzene sulfonil chloride. So if it is, this is the primary amine. If it gives white PPT, which is soluble in NaOH, then it is primary. Next, white PPT insoluble in NaOH, secondary amine. There is no white PPT, then tertiary amine. This is the one of the distinguished between primary, secondary and tertiary amines. Okay, this is benzene sulfonil chloride, important for humans. Okay, so the students, The main thing here in this is they will ask 2 plus 2 plus 1 question rather than 3 plus 2. Are you getting? So listen, only 3 reactions are there. Sulfonation, acylation, one second. Okay. Sulfonation, nitration and acylation. Okay. And also bromination or acetylation of aniline. So students listen. In the acetylation of aniline, remember. So this is the aniline. So NH2 group is there. You know, in the priority, NH2 group is more reactive than the remaining. So this is involved in the resonance, means the lone pair electrons on this group, NH2, these lone pair electrons involved in resonance, they disturb the stability of the compound. So that's why we need to protect this NH2 group by treating with acetic anhydride. So then what happens? They form, it is CH3, C double bond O, CH3, CO twice, O, acetic anhydride in presence of pyridine. So then what happens, students? Here, this group is protected like this. CH, NH, okay, C double bond O, CH3. So this group is protected. So when this group is protected, so followed by hydrolysis, it may changes to again NH2 group. With this acetic acid CH3, C double bond O, OH. This is amine on reduction, sorry, on reaction with acetic anhydride in presence of pyridine gives this type of compound, right? So followed by hydrolysis, again follows this, gives this amine. So this technique is used in the electrophilic substitution reaction. And remember, argon and para products are the major products here, but here this is the bulkier group. Means if the nitrogen is here, it will be like that. NH, so C double bond O, CHHH. So this is the bulkier group. So ortho position cannot be free for the substitution. If any atom is present here, there may be a repulsion between these two. So that's why the para product here is the major product. Are you getting? The product, para product here is the major product. So if you do bromination, first I take, if you do bromination now. So in the bromination is benzene ring, that is especially aniline. So it is treated with the CH3CO twice in presence of pyridine. Gives this compound NH, C double bond O, CH3. So once the group is protected, now forms bromination. Bromination in presence of what? In presence of acetic acid. If it is bromine water, we are getting 2,4,6 tribromo aniline. But here, in the presence of acetic acid, when it is protected, we are getting NH, C double bond O, CH3, and here we are para bromo aniline we are going to get. So students, now we need to change this to what aniline means. We have to do hydrolysis, acid hydrolysis especially, in presence of any acid. Acid hydrolysis, therefore, this is NH2, this is Br, and CH3, COH. What is this? Bromination. Similarly, if you take nitration, so what happened with nitration? So students, here same anilene or anilene. Again, it is protected by this group, acetic anhydride in presence of pyridine, forms of protected compound NH, C double bond O, CH. So after the group is protected, now the nitration takes place. Nitration means mixture of concentrated HNO3 and concentrated H2SO4 at 288 Kelvin. Both are concentrated here. Concentrated HNO3 and concentrated H2SO4. So students, note down here, the product formula is NH, C double bond O, CH3, NH2. Now, so the followed by acid hydrolysis gives para-nitroanilene. Para-nitroanilene. This is para-bromoanilene. So next, if you do sulfonation, then this is aniline. So it is treated with CH3, COO in presence of pyridine. Now, so this is image C double bond O, CH3. So students, here we are doing sulfonation, means we are using concentrated H2SO4 as a reagent. So when we use concentrated H2SO4, okay, so at which 450, 473 Kelvin, 453 to 473 Kelvin. Therefore, S43 H3. So for hydrolysis, they form para-sulfonic acid anilene, para-substituted anilene. Okay, so this is about what? Bromination, sulfonation, and also nitration. So students, instead of protecting this group, doing this, if this anilene directly treated with concentrated H2SO4, before doing this group, if it is treated with concentrated H2SO4, therefore NH3 HSO4, this is plus, this is minus. So again it is heated up to 453 to 473 Kelvin. Then they form here NH2, here SO3H plus H2. This is another one. This is also one form. This is also one form. Wherever, whichever the way it follows, the product formula is what? Para-substituted product. So this is all about the complete reactions of anilene. Only these reactions are important for examination. Go through these reactions, you will get 5 marks compulsory. Understand? Okay. So this is all about the organic chemistry. So students, in the tomorrow's class I will explain the nomenclature and classification of these 4 chapters, and later I will explain the biomolecules chapter. Thank you.